Alright friends, so here is the exact problem statement before us. Two particles, same starting point, moving in opposite direction, and after some time the velocity vectors become perpendicular. Sounds simple, isn't it? But this single problem involves multiple concepts and there is a hidden trick also. So friends, welcome to Numerical Studio, where we try to make physics not memorize but to visualize. And you can see the problem before us is taken from the book Irodov, in which it states that there are two particles that's moving in a uniform gravitational field. Whenever you are mentioning this term, moving in a uniform gravitational field, you should consider that you are more or less dealing with a motion under gravity or a projectile motion. Both these two are the cases of motion under uniform gravitational field. Now at the initial moment, the particles were located at the same point. You can see they are located at the same point. Okay, so let me choose this. Okay, so both the particles are starting from here and they are moving in the opposite direction. One has started in this direction, another is starting in this direction. There are two particles, P1 and P2, and we have to find out the distance between the particle at the moment when their velocity vectors become mutually perpendicular. So let's see, after some time t, this particle is at point P1 and this particle is at point P2. Sorry, this particular tangent is not touching it. Assume that this is touching the tangent. Okay, so that it can give us the direction of the velocity vector, and this velocity vector is V1 and this velocity vector is V2. Okay, or you can say V1F or V2F. Final. Okay, this is the velocity vectors. So as I told you, there are multiple concepts involved in this problem, and one of the problem is the product of vectors. Okay, so friends, what do you mean by product of vectors? In normal language, we can say product is nothing but the result. Product of vectors, that means results of vectors. Okay, we can also use this as results of vectors. Another way to interpret this term product as multiplication of vectors. Multiplication of vectors. So what do you get when you multiply two vectors? And there are two ways to multiply vectors. First, if I'm just multiplying V1 cross V2, I'm explicitly saying here cross. If I'm saying V1 cross V2, then we'll get resultant as a vector. Okay, we are not going to deal about this particular thing right now. We are going to discuss about something different. So what if the two vectors are multiplied in such a way that we are getting a scalar? Okay, in that case it is called dot product, because we are just putting a dot between these two vectors to output as a scalar. Now if you see that B and A are two vectors and they are inclined to each other at an angle alpha, then from this right angle triangle we can say this particular line can be this particular line is nothing but the projection of B in the direction of A. This is what? Projection of B in direction of A. How? You can use simple formula of trigonometry. This is B by H, this is base, this is hypotenuse. So base by hypotenuse is nothing but the cos theta. So we can say B equal to H cos theta, right? Since the angle is here alpha, so we can write as B cos alpha. Now see, B cos alpha and A is now pointing in the same direction. Okay, that means they are almost parallel. So A dot B, if A dot B needs to be the scalar, then in that case we have to take the magnitude of A, because magnitude are always considered as a scalar quantity, and B A B cos alpha, where B cos alpha is nothing but the projection of B in the direction of A. Okay, so this is the way we are representing A dot B. That means we are just multiplying two vectors in such a way that we are getting scalar as a product. Okay, friends, I think we are clear on this part. Now let's try to understand the another portion that is involved here. That is the motion under gravity. In last numerical also, I'll just put in the I button. We have discussed a problem regarding motion under gravity. And motion under gravity, again I told you that each and every vector quantity needs to be calculated by giving direction into account. So you see that there is a man who is dropping some ball, and I have considered this is y axis and this is x axis. If you just try to consider this is a reference level of your dropping of the ball, then all the direction, if you are considering in upward direction as positive and downward direction as negative, so h can be written as minus h in terms of displacement. The velocity given in this direction, if any, can be considered as negative. The g, the motion of gravity, g is already, I told you, this g is in negative direction, so acceleration is nothing but minus g. Okay. So similarly, only the time is positive, because whenever we start an event, the time starts getting positive. Time is negative, that means time before the event, that is no longer going to be counted while calculating some physical quantities. Now, we have again understood that the final velocity can be written as u plus at in case of constant acceleration motion. So in this case, we can consider the v final can be u initial, a can be written as minus g and t, but ui is also negative, so you can write minus ui minus gt. Okay, this is one more thing. In this case, if I just want to find out the velocity at certain point vf, then this vf can be given at like this. Okay friends, now one more thing is there that I just want to ask you in general. Suppose there is a block is placed over a table and it is moving with some velocity u, and if you are putting up, and this entire thing is so smooth that there is hardly any friction. Friction is almost negligible. Okay, there is no friction, there is nothing as a, it is not a rough surface, it's a absolutely smooth surface where the velocity, the reduction of velocity due to friction is almost zero. Now if you just want to increase the velocity of this u of the particle to v, okay, what you have to do, you have to apply some kind of force. Okay, that is our practical experience, and force has to be applied in this direction. So if your force is parallel to the velocity, in this condition, velocity increases, isn't it? So whenever there is a force, force may change the velocity, maybe in terms of its magnitude and sometime in terms of its direction, but ultimately force definitely bring a change to the velocity. Now see, this is a particle's trajectory. Now let's come into the problem here. This is a particle trajectory and this is the direction of g. Okay, we are just considering this particular frame as a reference frame, and this is the positive y direction and this is the positive x direction. So this v2, that is in I direction, this is the j direction, the unit direction that points to the direction of y axis, and this is I is pointing in the direction of x axis. So I just want to find out the velocity at this particular point. Okay, now you just see, if I'm just dropping a ball here, just for a calculation only, I'm just dropping a ball here, and this ball is at this particular point. Suppose this is the v1 and the v1f, and this is the v1. Okay, then this is the angle. Okay, let's try to solve this. Suppose I'm just considering this is x-axis, this is x-axis, this is y-axis, and this is okay. So this is the tangent. Okay, this is the tangent. Now if I'm just considering this, suppose this angle is alpha. Suppose I'm just considering this particular velocity is making an angle alpha with the x-axis at particular time t at this point p1. Then we can see that it will have two components. Okay, one will be v1 f cos alpha and one will be v1 f sin alpha. Now sin alpha is going in the y direction, okay, and cos alpha is going in the x direction. Now what is the velocity, initial velocity in x direction? The initial velocity in x direction was v1, okay, and this is negative in this case. Okay, and what is the final velocity in x direction? Ux equal to nothing but v1 minus v1 f cos alpha. Okay, now see, there is no acceleration in x direction because acceleration is only working in the y direction only. It is only in the motion, the gravity is there. So we may write that vx equal to ux plus ax into t. Then vx can be written as minus v1 f cos alpha. F is the final only. We should not consider f is some force. Minus v1 is equal to, this portion is 0. So that means there is no change in horizontal velocity. Horizontal velocity is almost same, right? because we are not putting any force in the direction in the x direction. Now what is the velocity in the y direction? So Vy can be written as Uy plus acceleration in y direction into t. So Vy is written as V1 F sine alpha, can be written as, there is no initial velocity in the x direction because the velocity was only given in the x direction only, there is no velocity in the y direction. So this is 0 and this is gt. Okay, so this is V1 F sine alpha is gt. Okay, now V1 F sine alpha is gt. Okay, similarly for V2 F sine alpha can be written as gt also for this direction also, if I just consider this one. Okay, now if you just multiply this two, okay, if I just divide this two, this angle will be something different. Okay, because you cannot say, because we need to find out what is the velocities. Okay, sorry, this I should not say this is sine alpha, this should be sine theta, some other angle should be there. Okay, so let's be another angle, not the same. Okay, now let's try to find out, let's write everything in terms of vectors first. So first vector I can write V1F as a whole, I can write V1F in x direction plus V1F in y direction. So V1F in x direction is nothing but the V1 plus what is the this is the GT. Okay, V1F from this equation, V1F cos alpha. This one, where is Vy is nothing but Uy plus Ay into t. So this is G minus Gt. Okay, minus Gt. So this is the overall velocity vectors of this particular ball in this direction. Similarly, for other vectors, we may write V2 minus Gt, and I direction is there and J is there. Okay, because we are writing in the vector format. Now let's see, try to find out if two vectors A dot V are perpendicular. What does it mean if A and B are perpendicular? We just saw that A dot B is nothing but mod A, magnitude of A, magnitude of B, and cos theta. So theta is 90 degree here. So A, B cos 90. So this will be 0. So that means if A dot B is 0, that means two vectors are perpendicular. So let's try to understand the problem once again. We need to find out what? We need to find out the velocity becomes mutually perpendicular. So that means we have to multiply these two vectors, V1F dot V2F vector product should be 0. So we may write V1 V2 minus G square T square equal to 0. So that means T is nothing but root under V1 V2 by G. So this is the time at which both these vectors will be perpendicular to each other. Now we need to find out the distance also. How we are going to find out the distance? For calculating the distance, I am leaving on to you. If you don't able to solve this problem, then because I have not touched that concept of displacement in a constant acceleration motion, so I am not touching it right now. But since I have touched this particular portion of velocity, finding velocity at a given point of time, that's why I have touched the first portion of this problem, that is at what moment these two velocities will be perpendicular. Friends, in our Instagram channel, we have posted one solution, one problem statement that is a little bit advanced of this particular problem. I wish and I want to see that how many of you can solve that problem and send me a solution to us. One more thing is there is an Telegram channel we have created, and we are posting all the things apart from the PDFs and POIQs. So the students who are just try their hand in some other problems apart from the 11th one, on 12th also, they can go and check it out. And that's all, friends. That's all for the day. And I just want to request you one more time, please do not forget to subscribe, because your subscription will give us the motivation to work more harder, to bring more quality material for you, and ultimately it will help to achieve our objective, that to make physics easy for you, not a nightmare for you, and to give and to fetch you a good marks in your examinations. And at the same time, it will be an encouragement for us also for our efforts. So thank you, friends. Thanks for your time, and have a great day.